In 55 on page 155, we have y is 2 over 5x to the third, and they're asking us now to find dy over dx, and this is how we write it when x equals 4. So let me stop sharing so you can see. So this is the question. You can say, why are they using this notation? They can just simply say f prime of 4. That's what it is. Why don't they just call this f of x? Yeah, they want us to use the other notation, which is a good practice. So we either denote this by f of x and then we find f prime at 4, f prime of x at 4, or we just stick with the notation to practice that. So let's continue. I always tell my students the keywords in math. Keywords in math are factor and simplify, whenever applicable. What is applicable here? Something that I can apply here to simplify it, because this is more difficult. So I'm going to change this into y, and that's why we discussed the exponential rules. 2/5 times x to -3. How do I know that this is correct? Because 2/5 times x to -3 is 2 over 5x to the third. This is more convenient for differentiation. This notation is not convenient for differentiation. So I'm going to simplify it, changing it into something easier to find the dy over dx, the derivative of y with respect to x. So then I write dy over dx. If you don't like it, you can write f prime. It's acceptable. Everything is the same. The constant will stay in front. Remember the power rule. I have to bring the power in front. So that's multiplied. I have to put parentheses. If you forget parentheses, this will not mean multiplication anymore. You need parentheses when you bring -3. If it's not negative, you don't need parentheses, but it's negative, so you need parentheses. You cannot have these two operation symbols without being separated by parentheses, sitting one next to each other. Okay, times x to which power? I bring the power in front and I subtract 1 from the power. So what do I get as the power here?
-2.
-4. -3 minus 1, -4. Is that okay? So now this is over 1, right? Any number is over 1 unless it's in the denominator or whatever, right? So this is -6 over 5. And x to -4, now it can be brought to the denominator because it has a negative exponent. And this is it. What does this represent? It represents the rate of change of this function f everywhere where this is defined. Can anyone tell us where this function will not exist?
Be 0?
Exactly, thank you very much. The denominator cannot be 0. So we didn't finish the problem. We are asked to find dy over dx when x is 4. Okay, no worries. Dy over dx when x is 4 is -6 over 5 times 4 to the 4th power. So I don't know, I did not read. We can read now if they want an approximation, if they just want exact. They didn't say anything. So I will multiply 5 by 64. But okay, I'm going to write 4 to the 4th. So I got 1280. So -6 divided by 1280. And I will simplify by 2. By 2 and I get 3. By 2 and I get 640. So the final answer is -3 over 640. That's the rate of change, the instantaneous rate of change of the given function when x is 4. It's this, whatever this represents. Any questions? Any questions, please?
So
Yes.
how does this differ from a regular prime? Like, I'm kind of confused on how it's different. Like the dy over dx is different.
Different from?
Different from like a regular f prime.
It's just a different notation. It's not. So this is the same thing with f prime of 4. There is no difference, other than it's a different notation.
Oh, okay.
Yes, it does have some significance, and I will explain the significance of these two pieces in the next chapter. Actually, in chapter 3, to be exact. So I will explain again, and we'll come back to this notation, and we will discuss what these two pieces mean. But for now, all you have to remember is that this is a different notation called the Leibniz notation, and this is the same. This notation is saying find f prime at 4.
Okay, thank you.
Thank you. Okay, so I would like to look at a word problem. No, not here. Here. Okay, so let's look at life sciences, the growth of a child. Now, of course, if you, after we do this, if you want to go back to any, find the equation of the tangent line to the graph, we can choose. This is much easier right now because we don't have to go through all those steps of the limit of the difference quotient, right? We are just using differentiation rules. So let's look at a word problem now. Growth of a child. The median weight of a boy whose age is between 0 and 36 months is approximated by this function, which is a cubic function. It's a polynomial function. Is the polynomial function always continuous? Anyone?
Yes.
Always
Yes.
continuous. Does it have any corner? Not the vertex. The vertex is not a corner. Does it have corners? Does it have cusps? Any issues? No. Polynomial functions have no issues whatsoever. Domain all real numbers, differentiable everywhere, continuous everywhere, no issues at all. Good. So T is in months and W is in pounds. So let's see what they want us to find. So when it's asking us to find the rate of change with respect to time, of weight with respect to time, coming back here, which of these, of course, you will never say the fourth one because we haven't discussed it, but which concept from these three are we asked to find? Let's read it again. The rate of change of weight with respect to time. 1, 2, or 3?
One is the average rate of change between 2 points.
We don't have 2 points, so this can never be. We don't have 2 points. It says, again, let's read it again. That's why the concepts are very important. And maybe, at least at the beginning, we need to emphasize this. The rate of change, it does not say the word average. If it doesn't say the word average, we cannot choose number 1. The rate of change of weight with respect to time.
Number 2.
Yes, the rate of change of weight with respect to time. It doesn't say find the rate of change when number of months is 2. No, it says find the rate of change of W with respect to time. So it's number 2. Awesome. So let me copy. I'm on page 7. So let's copy the function. So this was 87 on 155. And the function is W of t. So this is pounds and this is months, so we don't forget. So 8.15 plus 1.82t minus 0.0596 t squared plus 0.000758 t cubed. Okay, so in part one, they're asking us to find W prime of t. That's all they want. Good. So let's start either from here, but I would rather present it in descending order. So it doesn't matter. You tell me. You want to start in this order? I will do it in this order. Yeah, let's do it in the order we see it here. What is the derivative of a constant? Anyone?
0.
Perfect. What is the derivative of t? Remember, t has power 1. When we differentiate t, we bring down 1, and we subtract 1 from the power. How much is 1 minus 1?
0.
Perfect. What is t raised to 0? And this is very important. Only when t does not equal 0. 0 raised to 0 is not 1. So the answer is 1. This cannot be 0 and this can be 0 at the same time. It cannot be. If this is 0, this won't be 0. It's not possible. They're not the same. So t to 0 is 1, assuming that t is not 0. 0 to 0 is not 1. This is an indeterminate case. Okay? So then I have 1.82 minus, I multiply this by 2, 0.0596 times 2t, and I subtract 1 from the power, and then plus 0.000758 times 3 times t to the second power. I brought 3 down to multiply by this, and subtracted 1 from the power. And I will have to perform these calculations. Let's see what I get. 1.82 minus. So this is 2 and 1, 18, 9 and 1, 10, 1, 1. So 1, 2, 3, 4, 1, 2, 3, 4. Correct. And then plus. So let's multiply this. So 4 and 2, 15, 7. You just give me one more second. 21, 22. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. T squared. Yes, I'm answering any question now.
What do you do with A again?
What do I do? What do I do with what?
What happened to 8.15? And can you explain me one more time?
Yes, I asked before, what is a constant prime? What does it equal to?
1 or 0?
You know the or. What is the rate of change of a constant?
0?
Yes. That's what I said. If you have $10 in your pocket and you don't put anything, you don't take out anything, what is the rate of change of that constant?
0.
Perfect. So C prime is 0. So 8.15 prime will be 0. When I differentiate this term, I get 1.82. When I differentiate this term, I bring 2 in front, I multiply, and I get this. When I differentiate this term, I multiply by 3, subtract 1 from the power, and I get this. So this is the function. Is that okay?
Yeah.
Perfect. Now in part B, the weight of a boy at age 10. What am I asked to determine in part B? The weight of a boy at age 10 months.
Is it pound?
Yes, But how do I determine it from what you see here? Yes, so T equals 10 months. So what am I asked to find? What do you think?
You just plug it in.
Yes, in which one? Because we have two functions now.
Origin.
Yes, so in W of T, I need to plug in 10. So W of 10 will be 8.15 plus 1.82 times 10 minus 0.056 times 100 and plus 0.000758 times 1,000. We're going to do that in a minute. Final question. The rate of change of a boy's weight with respect to time at age 10 months. So I'm coming back here. Which of these four questions, well, actually only the first three, which of these three questions are we asked to determine now? Anyone?
Is it number 3?
Exactly. Excellent. I'm asked to find, after I have the rate of change, I'm asked to plug in the rate of change 10 months. Exactly. Perfect. So in part C, can anyone tell us again, what do I need for T equals 10? What do I determine now? One more time, anyone?
The instantaneous rate of change.
Correct. In which function do I plug it in?
The second function, which equals
W prime of, yes. So this time we're asked to use W prime because this is the rate of change. This will give us the instantaneous rate of change. So W prime of T will be 1.82 minus 0.1192 times 10 plus 0.002274 times 100. Okay. So let me look at time because I always go over, and I as a token of respect to you, I can do that. So please plug it in here and for next time, and plug it in here. I just need the measurement units, and I'll stop, and we'll determine these numbers. Please determine them for next time. So the weight at 10 months. So what is the measurement unit here? Anyone?
Was it pound?
Perfect. Now be very careful now. What is the measurement unit for the rate of change? It cannot be the same.
Pound per month.
Thank you very much. Because this is the rate of change. It has two measurement units. Thank you very much. Thank you. Sorry for keeping